Hey everybody, this is Larry. This is day 2 of the July Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about, this problem. Apparently this is going to be the same as yesterday's, except for is part 2 maybe? Yeah. Before I start, I want to say this is my day 1, week 1 of the marathon training. It ramps up slowly. I only did 4 miles or 3.5 miles or whatever today, but it will get harder. So this is my journey. Let's do them together and stuff like that, right? Let's go. All right. First of all, I saw something about mods, so I just kind of set up so I don't forget. But okay, is this different than the other problem? Well, let's see. There's a K, right? There is a K, which maybe means something, maybe not, but let's take a look. Maybe we saw most the time. You're also given integer K. Hey everybody, this is Larry. I've been cutting in this video because this is a long video, right? I think we all, you click on it, you see the length. I think you agree. I want to say this. There are prerequisites for this problem. This is a ridiculous problem for an interview. If you get a problem like on this difficulty for this interview, I would just leave because it's just not a good use of your time, I think. It's a ridiculous problem. It's a very hard problem. It's a problem that maybe through repetition you're able to get it, but it's a very hard problem if you haven't seen something similar. Here are my prerequisites for you for understanding my solution and my explanation. The reason being that this is already a 2-hour video, it's very hard for me to go from first principles all the way up. My apologies. But my first prerequisite for you, and you feel free to kind of skip ahead or whatever and play around with it and learn the way that makes it so that you can learn, right? It's dynamic programming. Spoiler alert. You have to be relatively good at dynamic programming. You're able to get something like this within, relatively soon, relatively quickly, right? And then the second is prefix sum. With those things, that's the prerequisite for this problem. If you don't feel like you're 100% strong in either one, I just urge you to kind of just skip this, copy paste the solution if you have to, if you want to keep your streak. I give you permission to, because this is a ridiculous problem. And just for today, solve a dynamic programming problem that's more on your level, or solve a prefix sum problem, which I guess you could also call dynamic programming, but this is a special one for this problem, right? That's it. Thanks for watching, and if you feel like it, I will explain next. And then, the way that I structured this one is that this is this part. There was the intro you listened to. There's going to be the I'm going to explain it for like half an hour, because that's half an hour, even assuming you know dynamic programming and prefix. And then after that, there's a live portion that's like an hour long of me trying to solve it live. I solved it live, but it took me a long time because a lot of this problem also hinges on analysis, complexity analysis, which I was kind of wrong about. I thought it was going to be too slow for a long time. Anyway, that's it. Thanks for watching, and let's get to it. Hey everybody, let me cut in. If you're watching this, well, that means that I've edited. This is a live channel, I know, and you still can watch me solve it live, but I didn't want you to sit in 1.5 hours of me thinking and then solving it. So I'm going to put the explanation here in the front, and you could still watch the live portion. You'll see how I progress. I think one benefit of this channel, and this is why I do it this way, is that I'm solving it live. So and I'm articulating my struggles and my step-by-step processes, right? And if you're into that, great. If not, I don't know, right? It's fine. But in any case, for this one, I have another video on this because I did it during the contest not that long ago. I want to say not that long ago, but it's almost October last year, so almost a year ago at this point, which is crazy. But in any case, yeah, there are a lot of things you can think about for this problem. the core part is coming up with dynamic programming. And I have some code here. You could be spoiled maybe, but we'll go over it a second at a time, right? The idea first is that you have to keep 7, or K, sorry, right? And as I alluded to, and I think I cut it, I hope I did anyway, I cut this before I mentioned some of the analysis, is that there is another way of thinking about it where you keep, you think about keep or remove or something, whichever one makes it easier. But here you have to keep at least 7. And well, for a lot of these characters, it's not a choice, right? Because for example, if you have like this, for example, if you have this string, well, the first A you have to press it. You just don't know how long you hold on to it. And then first B, first C, first D, right? So dot dot dot. So these are forced, right? Meaning, I say forced meaning that you have no choice, right? And then the choice you have is that, okay, let's say, I mean, this is a terrible input, for example, but let's just say you have more, right? Like a lot of C's, a lot of D's, and the characters, if they're not next to each other, they might as well be distinct, right? Meaning that if this is the same functionally as if you have just like A, B, A, something like that, right? Because it's just about this character, and then now you have this degree of freedom. And what I mean by degree of freedom is just that that's how long you could hold on to it, right? That's one, but it's also functionally, I want to say that because you're considering possible original strings and not possible ways to come up with it, which is different, right? And what I mean by that is that, for example, you have something like this, you have 6 A's. If you press A, hold on to it once, and then let go, and then press A again, and then hold on to it for 4 characters, it is still the same as pressing A once, or whatever, right? Once, but all the way through. It still gives only one possible original string. So, which is to say, it only matters how many A's that you've taken care of, right? Okay. Right? Okay. So then now removing these forced ones, then now it means that given, say, this input, you have, if you want to rewrite this in a way, and I'll show you how, you have 3 choices on the first thing, right? 3 choices on the first thing, 3 choices on the B. I don't know how many that is. Let's just say 10. I don't know. Maybe I'm miscounting it, but 10 on the C's, 3 on the D's, and I think 6 on the A's, right? So these are your degree number of choices. And let's say you have left, let's say K is equal to, I don't know, 15, right? 15 we have to subtract from each unique character. So 1, 2, 3, 4, 5. So 5. So that means that you have to choose at least 10 amongst those, right? And honestly, from this point, I knew how to solve it, but I thought it would be too slow. Why did I think it would be too slow? Well, this array, this array, given that n is 10 or 5 times 10 to the 5th, you can construct something like AA, BB, AA, BB, AA, BB, and then dot, 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 and this would give you 5 times 10 to the 5th divided by 2 number of, this array would have this many elements, right? And then if you times it by K for the number of states for DP, which we'll go over the DP in a second, but that was in my head, so then you have 2.5 times 10 to the 5th times 2000, which is going to be too big, I thought. But it turns out that a lot of the cases are not possible. So that makes it just fast enough, which honestly is what I call, I guess, I call this maybe like a proof the bounds problem, right? And what it means is that you can YOLO a little bit, and I did, because if you do the math on this, it is too slow. But if you do the math on this, it is too slow. But a lot of the states are not possible, maybe. So therefore, you can skip a lot of them. It's what, yeah. It's kind of what this is saying, right? Meh. I would also say that maybe I am wrong on this one though, because I think now that I think about it a little bit, I mean I thought this was a guess to bounce thing, but I think now that I analyze it, the way that I'm doing it live now, still, we do subtract one for each unique group. So that means that here there can be at most, given that k is equal to 2000, and we subtract one from each unique group, that means that we can have at most 2000 unique groups, right? Before it just becomes 0 by default. So maybe in that case I'm very wrong. Okay, I'm actually okay, fine. I think I'm willing to admit that I'm very wrong in that case then, because then now all the bounds will be 0 and then it just becomes linear. Okay, fine. Okay, so I think I'm wrong. This is a very, very hard problem. If you're watching here now and I still haven't mentioned it, I should have. But this is a very, very, very difficult problem. I mean, I took an hour and I had to YOLO and I had to come back to analyze it to do the, and analysis is hard too. But that's why I call it a little bit of YOLO, is because sometimes if you YOLO instead of proving, you may be able to get it quicker. But yeah. Okay, so then now, anyway, let's go back to this problem of, okay, we have to choose at least 10 amongst these, and that's easy, right? This is where you write a, honestly, this DP is kind of straightforward, at least if you're hoping to solve this problem. There are many similar problems to this one on Leetcode, easier versions of it, but you would write something like index and left, right? Where index is the current index, left is equal to the numbers we're forced to keep left, right? And then the idea here is, and I'm writing pseudocode kind of because, you know, and then now here is that if index is equal to the length of whatever this is, I just call it R for, I don't know, right? Then you return 1, or, well, okay, if left is less than or equal to 0, the other way, less than equal to 0, then return 1, otherwise we return 0, right? Hopefully this makes sense. It just means that if our constraint is met, which is that we have to reduce this to 0, then we return 1, otherwise we return 0. Otherwise, then we just do a for loop, right? Of, okay, it just counts up to this number, let's just say R sub index, if we call this an R array, right? Which is constructed from this. Out plus 1, that means that we have a choose 0, 1, 2, dot dot dot, all sub index inclusive from here, and then you write something like okay, well, total is equal to 0, total we added by go index plus 1, left minus I, right? And then return total. There's some optimizations that you can do, and of course you have to remember the mod, right? But that's basically how you would do it in a normal problem. So this part I actually knew very quickly, or like in my head, but I didn't want to write it out because I think I just didn't realize this proof. Now that I see it, it's kind of beautiful, but also like ridiculously hard to reason. Maybe, I don't know. I say I don't know because this is one of those things where when you know the answer, or when you know the observation, when you see the observation, you're like, oh, of course. But when you don't see it, you're like, wow, what am I missing? And if you watch the live version afterwards, I just spent an hour and 15 minutes on this problem, right? Or whatever it is. So it is very long, and I didn't see this part, which now that I see it, then now I can see why this, now it is bound by k squared, almost, right? Something like that. It's actually less than that. I think it's like k over 2 squared, but still O of k squared is the limit, actually, right? But okay, so let's say you have this, but this is still not fast enough, just to be clear, right? Why is this not fast enough? Well, because index goes from 0 to even, let's just say 2000 for math, right? Because it has at most 2000 groups. Left can go from 0 to 2000, say. But here, let's say you have 2000 elements. That means that each of these will have, like, I don't know, 250. Right? So, right, something like that. It's back of the envelope, but you can change it around if you like. But still, this is too slow, right? You have 2000 times 2000 times 250. Still too slow. That's like a billion, right? So the key point about this is, I like to, for these prompts, I like to draw it out, actually, right? For these DP problems. And then if you draw it out, let me bring up the drawing thing. Sorry, that's why I'm taking so long. I need some grid. So let's say you have a grid, right? And then here, actually, let me just. Right, so this is your DP grid, very ugly DP grid, right? No attempt to, okay. And you can think about, and this is a DP grid of how you store your things anyway, if you wanted to. But let's say, this side is index, and this side is left, right? And these are the dimensions that, our input is in. So then now, if you look at the formula that we wrote real quick, this is a for loop from index, if you kind of read about it, then now what is the, well, it always goes to index plus 1, right? So, okay, what does that mean? This is so annoying to go back and forth, but that means that for this cell, index plus 1, let's just say, is in the bottom, right? Or plus 1 is in the bottom direction. It goes into here, right? And then now let's look again at that for loop. Well, I goes from 0 to r minus index. So that means that left goes from, well, left to where, so this index goes from left I minus I goes from you go 0 to r index inclusive, which means that left goes from left to left minus r of index, right? Something like that. And if you kind of draw the visualization out, what does that mean, right? That means that, I don't know why I'm not clicking right. Why is this weird? Why are you being, oh, my pencil was upside down. Okay. Yeah, so that means that for this cell, you're looking at here, which is left minus 0, right? Here, left minus 1. Here, left minus 2. I'm going to just write L for short because I'm lazy, and then that looks like a 1. But then dot, 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 right? So then now, for this cell, it is the sum of some amount going up to R of index, right? And then now, if you think of this grid, okay, so maybe I kind of drew it all the way out this way too much. But if you look at another one, maybe, let's say, I'm using another color. Let's say you have this cell. That color is not bright enough. Hang on. Let's say you have this cell, right? And then now R of index is equal to, say, 3. Then now you want to be the sum of these 3, right? And for this problem, or at least for this video, because it's already going to be 2 hours long, I am not going to go over prefix sum. Unfortunately, this is a very, very hard problem. I don't know why they give it on day 2 of July, but this is a very hard problem. I'm going through a lot of concepts, so definitely feel free to just kind of, I don't know, just, you have my permission to skip it, is my point, because this is a ridiculous problem especially if you're a beginner. But anyway, if you look at it in terms of DP, and for this one, also to be clear, I expect you to already be very good at dynamic programming, because if you haven't followed along how I did this, I mean, even coming up with this is not, like, if you, with practice, you should be able to come up with this, but if you're a beginner, you're probably not coming up with this quite yet, to be frank, right? Oh, I didn't remove it. I meant this thing, this code, without the optimization. Even without the optimization, I think if you are interview ready, you should be able to come up with it. But if you're a beginner, you might struggle with just this part. And now I'm proposing an additional optimization, which is this thing. And with this thing, you need to know DP very well to be able to draw this out, and then also prefix sum, right? Because now, here, looking at the red one for a second, here you can see that we're basically doing a for loop to sum up the rectangle, right, from the next row. But you can, and this takes all of time, right, all of index, I guess, to sum it up, because you have to go through all of them, right? I'm drawing off the board, but right. But with this idea of a prefix sum, which I'm not going over in this problem because that's going to be another 10 minutes. But yeah, if you don't think you understand prefix sum and what I'm about to explain, solve a prefix sum problem. There's just so many prereqs for this problem. So yeah, okay. Then now, if you do a prefix sum, that means that for this green rectangle, you can just take this sum, right? The purple minus, let's just say, the orange, right? So then now, that's why I like to draw it out, because of this visualization, is that if you want to find the sum of or if you want to find green, and you pre-process the prefix sum, then you can do it in one calculation, or all of one calculation, which is to take the purple and then subtract it from the orange, right? So that's the idea. And doing this optimization allows you to kind of, I'm hand waving here, right? But now, if you're able to set it up beforehand, and we'll go over the full code, right? But I just want to kind of give you a step-by-step on how I came across it. And if you watch the live portion, I do it that way too. But this is how you remove this for loop, at least in theory, and we'll do it to practice later. This is how you remove the for loop into an O of 1. And it turns out that if you remove this to be O of 1, well, then now this is no longer true. The goal to 250 is no longer true. And then now you have 2000 square or something like that, and it is going to be fast enough. That's basically the core idea about this problem. There is some nuance here, of course, is that, for example, if you go back to here for a second, I kind of went by kind of fast, but I think the visualization will allow you to understand this better than, just the code. But this is not all the examples. I think the one more examples that I want to bring up is that if you have, say, if you're going over, say, this green square here instead, and now let's say all of index is equal to, I don't know, 1000, right? And then now, of course, let's just say this is left is equal to 0. That's the column, right? Well, you're not in this case. Then you're not only summing up this, because you also, what you want to do is actually you want to extend to the infinity to the right? Or not infinity, sorry. To basically a negative like 996 or something, right? Whatever, 1000 minus 4 or something like that, right? But however, in this particular way that we set it up, anything less than 0 is equal to 1. And that means that goal of anything less than 0, you sum up all the negatives. But because of that, one more optimization that you can do, instead of doing this for loop, is that all these values actually have the same value as left is equal to 0, as we define it, because you can think about left equal to 0 as condition met, right? So that means that all the other values that are before left is equal to 0 means condition is not met, and then now everything to the right side is condition met, and if the condition is met, then it will always just stay at 0. So you could, if you set it up, you can optimize it that way. And then just basically, in this particular example that we just did, that means that it is this case times 997 or something like that, because 996 plus one version of that at 0, and then you do the math that way. And that's how you solve this problem. Ridiculous, ridiculous, ridiculous problem. Something that honestly I got to be read in Topcoder without knowing this idea or technique or anything like that. So it is something that I think, I mean, one is that people are getting smarter, but two is that this is still ridiculously hard to figure out on yourself, on your own. Though I think I came up with it by myself, but still a ridiculous problem. Yeah. Anyway, let's go over the actual code real quick. I mean, I think the code is the code, but I want you to focus on understanding everything that just happened. And if you don't, make sure you get the prereqs in order, because you need the prereqs for this, right? It is what it is. Okay. And yeah, so first of all, we do the group by so that we kind of group all the characters together, and this gives us the length of the same characters and stuff like that. And of course, like we said, this is the degree of freedom, so we append s-1 if this is greater than 0, because if it is 0, or I guess if it's equal to 1, it cannot be equal to 0. But if s-1 is equal to 0, there's no point, because you have no choice, so you just can't do it. And then you subtract 1 from k, make sure k is at least 0. Gotta fail from that by accident. But yeah. Otherwise, then now this is the calculate function. This is what I told you about, right? And if you watch the live portion, I actually did submit this first with the for loop. I mean, I think I wrote this in a cleaner way, but it is essentially the same code. And yeah, right? And then here, we just kind of traverse it into a prefix sum. And this is the left side of the prefix sum. We either subtract it to get the smaller triangle, the smaller rectangle, or if we went over, then we have to multiply it by the number of times that we went over, right? We talked about this, and if you want to see the visualization for a quick second and pause, then this is the two scenarios, right? Yeah, this is the two scenarios. One is where you have to remove the orange part, and then the other is if you went over, and that's it for that part, right? And this part, maybe I urge you to watch the live portion, but doing the prefix sum is actually not that hard. Once you've done it a couple of times, I mean, you have to get that muscle memory. But even bottoms or even tops down, you can do it tops down, bottoms up. If you watched my other video, I actually do it bottoms up. But yeah, it is just that I convert this to index plus 1 left, and then this is the prefix sum function, as I call it, prefix sum function. And all it does is take f of index left is equal to calculate of index left plus calculate index left minus 1, calculate index left minus 2, ... right? Or plus ... right? Note that index left minus 1 is equal to all of this except for this, right? So yeah, plus ... of course. Notice this and then this. So if you kind of just use substitution, you have to substitute this into this, and then assuming you substitute it correctly, then now you see where we get this function. And that's it. And then the base case is, well, you stop at the base case, otherwise you're going to go into infinity. And that's it. And in the beginning, you start with the index 0 and k as your, remember, this is the new k after you subtract it by the number of unique things as your bounds. And that's it. Again, in this case, index can only go up to, I mean, it could be higher than, because index could go from 0 to r for the length of r in this case, rather, right? But keeping in mind that k decrements every time, so that means that if r is greater than or equal to k, then you automatically k is equal to 0. And if k is equal to 0, that means that this is linear, right? Because left is just 0. So it's just, you have a for loop basically in recursive form, right? Otherwise, the other thing is that if, so that's, yeah, that's this thing. Otherwise, if index is, I don't know, let's just say 2000, right? And it's not even right, but because I think 2000 k also is 0. But let's just say you have 1000, k is 2000, so you subtract 1000, so then now you have 1000. So then now this is going to be O of, well, n times, this isn't n, but it's some length of r, so that just called r times k, which is 1000 squared, right? And that's the possible inputs to here. Same idea with this one, exactly the same analysis, and that's basically the idea for this one. And that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, you can watch me figure out this problem next. Honestly, like the actual implementation wasn't that bad. It's just that I was not able to prove the bounds in this way. Because I thought it was n times k for the longest time, and I YOLO'd at the end because I just couldn't figure it out. And then actually only when I'm explaining this now on this part of the video did I realize that what I said here, which is why this is fast enough. Yeah, and that's it. That is all I have for this one. Let me know what you think. Like I said, this is a hard one. I give you permission to skip it if you want to, or just copy and cheat or whatever. I mean, it is a ridiculous problem for most people. So yeah. That's all I have for this one. Let me know what you think. Thanks for watching. But you could also watch me solve it live next, which is through this idea. Actually, let me click on this hint and see. I don't know if that makes it easier. I mean, I don't know. Anyway, that's it though. That's all I have for this one. Let me know what you think, and you could watch me solve it live next. Okay. I think I'm just looking at the example right now. I'm reading it, and I think I'm because we, just to kind of give a little bit of context, is that yesterday's problem, well, is the version 1 of this problem, and is it easy? We ran over it, but I don't think there's an k. And on that one, only one character it may held on for too long. But I don't know. Oh, yeah, okay. Well, no. Because I don't know in this one, maybe you can hold multiple characters for too long, right? And it's not super clear to me. And I guess this is the answer, right? Because if this is 8, what is the 8 for this problem? Because it's just like I mean, I know that technically they don't say it, so you can assume it, but this is a part 2 of a 2-part problem. You have one constraint, the other one. You should point out that look, this is similar, but it is not the same. Don't make the same assumptions, right? Anyway, so 8 I would imagine is AAB, AAB, ABB. B, AABB, AABBB, AAAB. I think I didn't enumerate it correctly. Yeah, let's do this one. Right, Something like this, right? I think I missed one because this is only 7. And you need at least one A, you need at least one B to kind of kick it off, right? I guess that's the idea. Oh, I just missed this one. Okay, so this is 8, and it confirms that my reading is correct, which is that multiple buttons can be held down, right? Okay. N is pretty big, 5 times 10 to the 5th, so you can't really do anything too funky. So let's think about this one. And you have this k thing, right? Another idea that you might have is k times n, but and I don't know how that would look like, but k times n is already maybe too big, I want to say. So that's like 10 to the 9, I think, if I do my math right. Maybe it's off by 1. By the way, even 10 to the 8 is too slow, so that's not it, right? Man, I was hoping for easy problems I could kind of lie down and rest up a little bit. But, okay. How would I even think about this? I mean, honestly, my most of my ideas are related to dynamic programming, which at the very least, like this, it doesn't work, right? So what would work? And there are a lot of them, which is true, because you can just say k is equal to 1, and if k is equal to 1, oh, I was gonna say if k is equal to 1, then you have all the possibilities. But actually, no, I don't think so. I was gonna say maybe we can enumerate, because k only goes up to 2,000, so maybe we could do like a loop over k, and maybe we still can, but I don't see a quick way of doing it quite yet. Or that isn't n times k, which is not great, right? Honestly, I don't really have any good ideas on this one. We have this idea of choice, right? Well, I'm trying to think whether I can do the opposite. And what I mean by that is that we have at least k. That means that you have to remove x characters from here or whatever. You could do the math on, and it's like n minus k or something, right? It's equal to x, so you could remove x characters, up to x characters. And then the question is, how many characters can you remove? Maybe that's a better way of thinking about it, right? Maybe that is a better way of thinking about it. Maybe, because then now maybe I could think about a combinatorial solution, right? Okay, just to reiterate what I'm thinking right now, because maybe I'm, sometimes I don't articulate it well and it's in my head, but we were trying to get a string of at least k, right? That means that given a string of length n, we can remove at most x characters where x is equal to n minus k. We can remove at most x characters and still satisfy, right? And then the idea then now is that if you have something like this, and I don't know the math exactly yet, that's why we're still working on it. You have something like this, then now the choice is that you could choose I want to say, there are 4 distinct type of characters, so it's almost, this isn't right, but my ideas are along the line of, and this is math free, so I have to figure out, but like 4 choose x or something, but it's not quite right. It's also, this is too low, right? Or yeah, this is too low, but then the other one of, okay, you have 2 choices here, 2 choices here, 2 choices here, and 2 choices here. So then that's total of 8 choices, chooses x. That's also not right, right? The reason being that this is too high. This is too high because if you have, if you just look at only a's, you have a removing either this a or this a does not change does not change like if you remove only one of the a's and it doesn't matter, and there are not 2 ways of doing it, right? Because I mean, there are 2 ways to do it, but it still gives you only one unique string, which is this one, right? Which is the possible original string. So there's only one possible original string, even if you kind of remove this one or this one. So that's basically what I'm trying to think of. So it's something in between these 2, but my math is really bad, so give me a second. But I think this is on the right path because if you have like a n choose not this n, but like some n choose k for some n and k, you could do that in linear time, right? So that, or linear in n, which is maybe not linear, depending on how you want to say it. But in this case, it is n items, so it is linear. But in any case, you could do that in linear time. So this is why I think this is on the right path, because it gives me the complexity that I think I want. But the question is that now we have to redefine this problem in a way such that we get this without counting, right? So you have... my math is so bad. And he's trying to do this without DPing, and maybe I'm just bad at this, honestly. Okay, because I think this is just relates to another visualization of. Okay, so you have like, you know, these things, and now you have to choose X of them. How do you do the math there, right? How do you do the math? The four things. I mean, the way that I would normally do it is by DP, but again, there can be a lot of these numbers. Is that true? I guess so. I mean, if you have 2 characters of every character in that way, then you have half of these, and then you have to do a 0, 1, K, so you can't do DP that way. But it is something like this, I think. And yeah, if you're joining me here now and you're already 10 minutes in, maybe this is a little bit late to tell you that this is a programming live channel, so once in a while you'll see me work on a problem where I actually struggle, and I'll try to explain it at the end, but so yeah, so fast forward if you're watching this live and you're like, wow, what is Larry doing? But if you're interested in the actual thought process and grinding it out, then, you know, stay tuned, because that's what this video is going to be like. It's not super common, but, you know, obviously, well, that's what I'm doing now, right? So, okay. So, I mean, at this point, it is a math thing, I believe. But, and just to maybe play around with an example, this has 8 characters, right? So that means that K, you have to remove up to 1 of them. Actually, and you could remove 0 of them. So maybe that's actually... maybe the math is a little bit weird, because you don't have to choose X, because you have to choose up to X, right? So that makes it even more complicated for now, at least for me. I mean, I think maybe I'm just wrong. Maybe this is just there's 8 items. We choose X, but is it just like that over factorial, over 2 factorial, 2 factorial, 2 factorial? Am I just being dumb? Maybe that is it, right? Because basically it eliminates the number of possibilities here of uniqueness, right? Okay, so what if this has 3? Then now this would be 9, right? 9, right? Oops. 9, right? Why is my keyboard working weird? Okay, 9, right? Oops. And then this is 3, which factorial, so that it eliminates 6 of these. I guess that's right. That's right, right? Maybe I'm just overthinking it, because I've been doing the... sometimes combinatorial problems I just struggle a little bit with. I think this is right, actually, and I'm just being dumb. Yeah, I think this is right, because then now, because you can, because okay, so non-adjacent ones, I mean, I know that there may be more A's in the end, but they're effectively for this problem different characters anyway, so it doesn't matter. So then now the symbols of it just becomes how many A's do you have, and then divided by the number of is this right? No, 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 no. No, no, no. This isn't right. I mean, I thought about this earlier. This isn't right because it's not this. It is it depends on the composition of the things you choose, right? So if you choose X, it's going to be like if you choose 2A's, then there'll be 2 factorial. If you choose 1A, is 1 factorial, right? Okay, so I think that's, and you can't, well, I guess in this case you can't choose 3A. If you choose 3A, then it's 3 factorial. So it's not as simple as that. But then how do we do it in a way that keeps it linear-ish, right? Because otherwise then we have to do some like, well, DP. And I think I'm just being dumb. I feel like this is probably a fundamental problem, a foundational problem, and I'm just like not seeing it. And it's also really hot here. I'm sweating like a pig, but once in a while I'm trying to keep my shirt on just to kind of, you know. But and this is a math problem, and some days I'm good at math, some days I am not. Yeah, I mean, we can try it out for this one actually, right? So here we have AABB, k is equal to 3. That means we have technically this. So we have 6, k is equal to 3, so that we move up to 3, right? So then now that is 4 choose 3 plus 4 choose 2 plus 4 choose 1 plus 4 choose 0. This one you can do the math on. It's like maybe, but the 4 choose 3 we have to yeah, on, and it matters because 4 choose 3 it's, and then those are the 2 that you choose, but it's just 4 choose 3 then, right? Well, I don't know. Maybe this number doesn't matter. Very confusing. Well, what about 4 choose 2? 4 choose 2, then now you have AA, AB, BB, right? Which is not right, right? Because you have 4 factorial over 2 factorial over 2 factorial. 12 over 4 is 3. Maybe I am wrong. Maybe that's it. And I'm just being bad at math today. So I thought I had to dedupe. I think that's why. And 4 chooses 1, it's just A and B. Maybe I am just bad today, and this is it. And then 4 chooses 0 is 0, right? And then now you have 8 things, which is the answer. Maybe I am bad. And now let's do it for this one then. Let's try it, and maybe I am just bad at math. Okay, so you have this. K is equal to 7. This string is 8. So that means that you have 4 choose 1. Well, wait, 4 choose 3. It's a little bit awkward. I think I just got lucky here though, because if I have more, then this wouldn't work, right? And I think this one doesn't really show either, because 4 choose 1. So then that's plus 4 choose 0. So that's going to accidentally be right. But what if we have someone like this, A, B, 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 K is equal to 3 again. So we will move up to 5. Well, that means that we move up to from here. In theory, then now if our previous math was right, then we have 6 choose 5. Right? Okay. I guess 6 choose 5 is right, because that's 6. No. That's already wrong, right? Because the possibilities are A and B, and that's it. right? Because or left, right? So I guess you can have to do, depending on how you want to say choose, but and that's it, right? So that's 2, but 6 choose 5 is 6. And the reason is because then now you have to do it by 3 factorial, 2 factorial, something like that. That doesn't even make sense. I mean, technically, I guess this is 3 choose 3 and 3 choose 2. And then you divide it by, or subtract it, or maybe divide it by. Yeah, I think subtract is fine. But then, like, that's not quite right, right? Because 6 choose 5 is equal to 6. But of course, you only have 2 cases because the other ones are kind of, you want to write it like this, then is equal to this. So that's how you get 6, right? So you remove the first one. So that's how you get 6. That's 6 choose 5. So okay, so I'm not too dumb in that. I think this was the reason why. I mean, okay, I drew this one wrong, so maybe I'm a little bit dumb. But it's not actually 6. They're actually 2 distincts, and it's because it's 6 minus I want to say 3 factorial times 2 factorial, but that's not quite right, obviously, right? Why am I so bad at math? Sorry, people pinging me real quick. I still have no idea, to be honest. I think we're still playing around with this idea. So okay, so it's not just this, even though the examples actually made it such that that's the case. Can't help it. K is equal to 2000. I mean, K is equal to 2000 enable us to do something like this, I suppose. But it's not right by itself, right? So how do I dedupe this? Am I just bad? I knew this was kind of wrong because the reason why it doesn't pass the sanity check or the smell test is because I know that this converges to, roughly speaking, 2 to the 4th, but that never makes sense when order doesn't matter, right? And what I mean by that is that order does matter for this problem in the way that we said here, right? Removing this and this one, or it doesn't matter depending on how you want to say it, but it still contributes only one thing given the order, right? But because this is 2 to the 4, and it implies that every number or every digit here is on and off binary as the upper bound, which cannot possibly be true when the ordering is ordering matters, right? Because here, if you kind of write it out, I don't know, a similar thing, then that's going to be 2 to the 6, and that's just not, as you see here, and that's basically what happens, right? Is that here we do look at every in some way every space that's not possible, or possible, not possible, on and off, and so forth. So then now we're trying to get this 6 into 2, and how do I do that? This is a very awkward one too, because I feel like the thing that's missing is more important than the thing that is lost, right? So how do I get from 6 to 2? Well, it's divided by 3. Well, I guess it's 6 choose 5 over 5 factorial over 2 factorial, 3 factorial maybe. Technically this times 2 maybe, just because of this. The 2 cancels out, the 3 factorial and the 5 factorial, 5 times 4 is 20. That doesn't make any sense. I don't know. Even if it's 10, it doesn't make sense. I don't know. I'm just trying random things. I'm just thinking out loud some ideas with math. But clearly, I'm very bad at it today, so it may be a long time. And you are watching me live. Thanks. And if you're here, hit the like button because I'm going to suffer for a little bit. How do I reduce this problem? I'm trying to think whether there are other ways to I'm trying to think if there are other ways to represent this. I mean, because going down this way, at least for me, for now, doesn't seem like the right path. But how would I do that? I feel like this is not it should be standard, but I feel like I don't know. Okay, well, another way to write it is, okay, so I mean 6 choose 5 kind of makes sense. We just have to get rid of dupes. And how do you get rid of dupes? 6 choose 5 is equal to 6. How do you get rid of dupes? I don't think I need to read it. I'm just double checking if I missed anything reading wise. I think k is equal to 2000 is interesting, but in that enables what we do now, because if it was just this, we can solve it, right? Like the summation of choices, but okay, what is that? Maybe 6 choose 5 is a weird way of thinking about it. But the other way of thinking about it for me is just DP, right? Like the DP one is, I want to say maybe straightforward, and that you just pick the number of A's, and then you have some number left over, and then you do it for B, right? And then so forth. So then you kind of pass it on. So then your dimensions, your states would be the character you're on, or the index, if you will, of your first character, and then how many is left of your K. But that's going to be n times k. That's the n times k algorithm that I keep on talking about, DP, which is, I think, pretty simple to do, but not fast enough. Unless I misread this, it's not fast enough. That's 50,000? Yeah, 50,000, right? So that should be too small, too big, combined with 2,000. What is this answer anyway? Well, this is choose 5 to remove. So the answer for this one is actually going to be ABB or AAB, right? I guess those are the two answers possible for k is equal to, I don't know, x is equal to 5 anyway. exactly, right? Hmm. Yeah, you should have took a nap first. Hmm. Eh. Okay, so what is here? Here there are is equal to 3 cases. Is there 3 cases? Is how many ways are there to pick this? Is what I'm trying to say. No, I'm like going back to here. I think that's the problem. So how many ways are there to choose this? This is just going to be, I guess, 3 ways. The way, oops, the way that we have it here. But how do you get to 3? It is man, I am just stumped today. I don't even have any ideas to bring about. N is still pretty big, lowercase, whatever. Okay. I mean, the implementation is not hard once we get into it, but the math part, you cannot grind, I suppose. And I'm certainly not grinding it well. Yeah, I'm still just thinking through, but what I'm thinking through is just whether if I had a DP, can I convert that and optimize that? I don't think the answer is yes, because I don't know that I don't think I can optimize away any of the states. Can I? I don't think so. Which makes it kind of tricky. I mean, otherwise, feel we've gotten it quickly. Am I struggling? I feel like I'm usually good at math, but today maybe not so much. Sorry, friends. Hope you're fast forwarding or whatever. Or maybe I do an intro in the beginning. But, can I do some reverse math? I mean, I think this is kind of the right idea. But I'm trying to think whether there's a whatchamacallit, stars and bars interpretation that I'm just blanking out on. So here, I don't think so, right? It's not just about putting things like this or something. It's and it is DP and so this. I don't think so. I want to say, like, what I was going to say is that maybe it's DP and there's some like weird cell pruning type thing that happens from time to time where, because of the way it is set up, it actually does. It's not n times k in the worst case, so it's fast enough. But I don't think so. I think you visit most of the states, or you could definitely construct an input in which you visit most of the states. Unless I'm missing something. I wonder if I'm just thinking like as a solver, right? But I guess that's not. I was thinking like maybe you could do a solver type problem, right? Of like, okay, this is basically you could convert this to like x1 is less than or equal to 3, x2 is less than or equal to 3, and then x1 plus x2 is less than what is it in this case, 5, right? And then count how many, right? Like that's another way of thinking about it. And of course, I was gonna say is, I mean, it's easy to find one solution, but count how many, or easy in the sense that that's integer programming, right? But and even then, maybe we have too many variables with n being too big, but that's definitely one way to think about it for sure. I guess technically we want to be precise. Is that true? No, you could select 0 from it. Well, I guess in this case, it's, I mean, yeah. I mean, I think if we set exactly 5, then we'll try to solve this one. But what if, but if it's, I mean, this is the problem, but how many count is there? Right. I think in general this is a DP problem, but I don't know. How did I do it last time? I'm trying to. I don't even know. I don't remember at all. People say I just remember all these problems. I don't even remember problems that I struggled with, and I probably struggled with last time. But Yeah, I don't know. I mean, this to me screams that DP. I think I'm just gonna YOLO it, get it wrong. Maybe I'm just wrong on my thing, and then DP because I don't really have any idea how to do it otherwise. But the idea here is that we have okay. Well, first of all, let's convert this problem, right? So now we have this thing. Let's just say we do a group by of word, right? Then now we have for GT in this, and we have length of list of T. Right, I just call this S for some reason. And then if S is greater than 1, then now we append S minus 1, right? And then now we do a DP on this array, right? So here, I don't know, try to be a little bit better, index, and then left, right? And then, yeah. But for I in range of R of index, so if index is equal to length of R, then we return 1. Otherwise, we count how many numbers we want to take from here. If left is greater than equal to I, then we just something like this, right? Maybe I should have done this a while ago. I mean, because I was stuck for a long time. But something like this, right? And of course you have to do mod, but that's fine. And then just calculate from 0, K, right? Let's see if this works. We have to actually just do a mod here. Line 62. Oh, how did that happen? No. Yeah. Okay, this is wrong anyway for some reason. Okay, why did I get 1? You have to be at least 5 characters, so you have to remove at most things. Should be right. Why am I wrong? Am I just returning 1 for everything now? But am I off by 1? Oh! It's not because left is not K. It's N minus K. We kind of talked about that, but I just kind of wasn't paying attention. Still wrong though. So at least we know that even if I didn't get that, it would have been still be no bueno. But why? I just try this to be infinity for now. Is that still too low? Because I'm just checking to see if it's too high or too low, and this seems like it is still too low, meaning something funky going on. I is equal to 0, 0, 0. Very good. All right. I don't get it. Yeah, we never. Oh! This has to be inclusive. I'm just dumb. Okay. Okay. So then now looks more reasonable, and then you have n minus k. Yeah, so at least now we're okay, right? Like it wasn't that hard, except for me being dumb, right? But this is gonna be too slow. That's the problem. I'm gonna YOLO submit because I have no idea what else I'm doing. But should time out, I suppose. Oh, memory limited, huh? Really? And but you can see that we're actually pretty close. I don't know why. Oh, maybe we can. If this works, I'm gonna be sad. I mean, I still think this should time out, but at least we should fix that. Though it's still sad that gives me a limit exceeded 6 seconds though. 6 seconds with 30 things to go is probably too slow. But, you know, at least we got a little bit closer to the truth. Yeah, I mean, that's fine. I mean, that I expected, kind of. The reason is because length of in this one, length of R is 1,000. 1,000 times 2,000 is actually not that bad. What about the other one? Also, I reused R by accident. Alright, let's just say 0. Yeah. Oh, actually, R is not even that big, so it's only 1,000 times 2,000. Oh, wait. But then there's a for loop here, so that's definitely not good. Is this a bit mask thing? Is that it? Am I forgetting a bit mask thing? Is that why? And it just has to be 64 times faster or whatever? Let's see, right? How do I convert this to... No, it's a count, not a boolean, right? Yeah, I don't think that's the case. But yeah, at least okay. Even though it may sound weird, there is comfort in knowing that it is wrong as expected, because otherwise then I just wasted a lot of time. Now, instead of wasting a lot of time, I'm still wasting a good amount of time though, and try to figure it out. What am I missing? I feel like maybe it's just something with this and I'm just missing the math. So okay, so at least my interpretation is not wrong, right? It's too slow, sure, but it's not wrong, like this setup. Though I was a little bit imprecise. I mean, even this n times k would be too slow, but I forgot that there's a for loop here, which obviously makes it even slower. But so it was never going to pass. But the only thing that wants to pass is me passing out. But man, I am 40 minutes in or 50 minutes in now. I have no idea. I feel like this is also like one of those things where as soon as you see it, and then it just becomes trivial. Or for me, maybe. Like in terms of like some kind of logic here that I'm just missing really badly. But this is a good illustration of why, but I just can't figure it out. I'm trying to visualize this dynamic programming in a grid and whether I can take advantage of it. It's still going to be n times k in the worst case though, but Well, maybe, but we're only even up to 1,000, and it's already not performant. So maybe we could definitely think about that. But this is just a silly math thing that I don't know. I don't know. K02000 is still bugging me. Like, I feel like there's some weird thing that I'm not considering. I mean, I did the reverse of stuff and that's fine, but it doesn't really change the problem fundamentally. Actually, if anything, maybe this is even worse because n, maybe that's, because now instead of bounded by k, it's bounded by n minus k. So I actually made this worse. So maybe you have to try, these are the things to keep. And then and then now in this case, if we keep these, then you have to something like this, right? And then now you could say if left is greater than you go to zero, if it's you go to 0, return 1, otherwise return 0. I guess this technically would make it a bit faster, depending on the k and the input, I suppose. I mean, it is faster than the other one. Gives me the wrong answer though, so it's faster but wrong. It's a tricky balance to do. Something like this. Maybe I'm off by 1. I'm definitely off by 1 by the number of unique things. So k, at least k, right? So that means that here every time we can subtract 1 from each group. Okay, right? So actually this is much faster. So maybe I'm just dumb. Well, I'll YOLO submit again, just for science, to see how much farther we get. I still think this times out though. Maybe I was just being dumb though. I mean, that was clearly a little bit dumb. And maybe we have to, max is a little bit expensive, but this for loop is still too expensive. Yeah, so we ran like 5 more cases or whatever. But also for science, let's, people ask me why I do this lambda thing is so that it just runs faster, the TLDR. Actually, this kind of added slower, but let's YOLO submit it real quick, even though we know it's going to be the time limit exceeded. But honestly, I'm a little bit stuck. Oh, see, a little bit faster. Not enough to get a AC, but still a bit faster. And then now, man, I really need to take that nap, and instead I'm working on this for an hour. An hour! Should have took a nap first. But yeah, this even just this has the potential to do a lot. Can I do better with the math here? Well, yes, because you can do this with prefix sum, because this is prefix sum dp. But is that fast enough? Is that optimization good enough? So okay, let me do the math on my head on how. I mean, I don't think this is fast enough still, but I want to make this optimization, which is that okay. Let's remove this for loop. How do I remove this for loop? Well, maybe we can just write so we want to write this I is equal to 0 all the way to I is equal to this, right? So that means that we want some function of index plus 1 that is from left when I is equal to 0 minus f left minus when I is equal to R of, and in this case we want all of them, right? So what I mean is that we want this to I to go all the way down because we want this to be less than 0 anyway. So okay, so something like that minus 1 because we want to be inclusive of left this, and you can kind of see this pattern as prefix summy, right? Here we do want this to be a this isn't right. I think we want this, and then if left minus or index minus 1 also is not right. I mean, if this is greater than 0, then total we want to subtract this, but else, because for every I that is under, you actually want this index because here, then now how many left over are there, right? So that means that this is this is if this is the this is the case, maybe it's equal to, but it's something like this. If this is the case, then what happens? That means that you have R index minus left extra ones of I mean, I think this is fine because it is just someone like this. Yeah, I mean this is equal to, but that's fine. Right, someone like that, and then now here. And this is just my prefix sum function. Also f dot cache clear because we want a memory boundary. Then now if left is equal to 0, we return calculate index left. Is that right? It's like a prefix something is very confusing. Oh yeah, I think this is right because this goes to the next one. Else return calculate index left plus f of index left minus 1, right? Something like that. Okay, it would be more helpful if this was closed, apparently. Okay, so this looks good. Only a little bit of a speed up, but still enough to YOLO submit. Maximum. Did I not have a base case? Did I not have a good enough base case? Index. Do I have this wrong? No, f is always index plus 1. Let's see. Do I have some weird thing? I guess so. What's so special about this case? It may also be that 1,000 is just not good enough. We could win this bottoms up, but I don't know. What is this? Oh, anyway. Hmm, 2,000, so not even that bad, but I wonder if this is a real one. Let me up the recursion limit. I always forget how to do it though. Python up recursion limit. Because I thought Leetcode has something for it. Because it used to be that you have to do it manually, but okay, fine. Fair enough. I mean, it might time out, but and memory limit exceeded, but at least like it shouldn't have Stack Overflow. But I don't know if this is a legit Stack Overflow with memory limits. Let's see if this. Let's print a couple of things and hopefully we'll get some idea. I don't know where we print negative from. Do we have other print statements? Why would we print? Oh, no. Oh, left is negative. Oh, because this is already negative. I thought this cannot be negative, so that's why left. Where do I have it? F max, this should be 0. This should be 0. Where is it? I mean, I guess that's why it's doing it, but how? Okay. Yeah, okay. What is calling that? K positive, left as positive as this is as positive as this, left minus 1, but it assumes that left is greater than 0, right? What's calling this that's not greater than 0 then? This is, unless f max is wrong, which I've done it before. X is greater than y, otherwise, yeah, f max should be greater than 0. I mean, I guess we can assert this. Okay, so that's right. And this is just 0. So it would calculate this automatically and it go plus. Why? How? Okay, so this is right. So then where is it going? I mean, I don't know. Maybe it runs out before. Am I going nuts? I mean, yes, but what is calling this? I mean, itself maybe goes to left is equal to 0. This left is equal to 0. Left is here. Wow. Even when I'm close, I'm not. Alright, let's see. Print index left. I mean, that is definitely Y, but why? It only prints one thing, so it's on the first call. I want to say. Or it's the first call where left is not equal to 0. Maybe I could print out here. No, that's the index is 1. No, this is a output limited. Okay, fine. Okay, fine. How? Why is left 0? Am I missing a thing? Alright, let's just erase all this now. I mean, I don't even know if this is the right answer, even if we get it right, but I don't know why this is wrong. Because who caused this? Did I call it elsewhere by accident? It's only this and neither of this and this, right? So why is left negative? I guess, but why is that even necessary? Okay, now it gives me the wrong answer, which is not surprising because I don't even know how this came about. And I don't have another print statement, do I? That's not from something else, right? So there are a lot of indexes. How? Why? How? Where is this coming from? Okay. So F. Actually, it calls it directly. So line 38. So that means this left. Do I adjust K by accident in something? Oh, I am dumb. So, okay, so it calls in this and then, okay. So that means that K is not necessary. Okay, fine. I am just dumb. Okay. I still don't know if it's fast enough, but at least we've done some stuff. I mean, this is all we can ask for. This is ridiculous. I don't know how this is fast enough though. And honestly, I had this idea the entire time. I mean, how did I do it last time when I did it during the contest? I guess I did it the same way, but how did I prove it last time? I mean, the reason, like, I kind of had this, right? Like, I knew how to do this. I think that was the first thing I said, even. Then I was debating doing it this way. I guess this is exactly the same way I did it this time, but more or less. I mean, I did bottoms up, but I honestly, I only started doing this because I gave up on being fast enough. Like, it was more YOLO. I don't know how I could prove this. I don't know if it's an input thing, because I feel like, all right, let's say, for example, you have a word that is, I don't know, let's just say AABB times, what's the max? Was it 50,000? So 50,000 divided by 4 is something like this, right? Huh, that is fast enough, huh? Because R, because length of R would be 25,000. It would be 25,000 times 2,000, which is like 50 mil, right? I mean, I guess not all of them are possible, but that is just, I don't know. I don't know if I knew it last time either, to be honest, but this is a very hard problem. All right, I mean, I am not going to, I mean, if you're watching this live now, I mean, I'm still on my weirdness about this problem. If you're watching this now, that means that I probably have recorded the explanation in the beginning. So thanks for watching all the way to the end. Yeah, I mean, I think the crazy, I mean, I don't know. I think there are two things. One is, I guess, don't be afraid to YOLO. I had this idea in my mind for a long time, but I just didn't think it was fast enough today. Because everything I did was pretty straightforward for me. I think this is a very hard problem. I think this is not a problem most people would be able to get, or even should be able to get. I don't know. Maybe ChatGPT is good at it, but I don't think so. But yeah, I don't know. It is a very weird problem for sure. I don't have anything to add. I mean, I'll go, like I said, the analysis I'll record after this and I'll cut to the beginning, so you've probably already seen it. Yeah, I'll cut it together. That's it though. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.